Alright, hey guys, it's Miss Scott again. Talking again about acceleration part 2. As I promised in my previous video, we were going to do some acceleration problems that didn't have to do with finding acceleration directly, but finding other variables using acceleration. Just to remind you, the formula for acceleration, for uniform acceleration, is A equals VF, that is final velocity, minus VI over your time, over how long it took you to go from that initial velocity to that final velocity. Acceleration is just the rate of change of velocity. So let's go ahead and get started with this problem. Remember, the first step for any problem that you are ever going to solve in your entire life is look at what you have. Look at what you have, look at what's missing, see how you can use what you do have to find what you don't have. So if you're in my class, especially my phys sci class, well, all my classes I should say, when you are first learning how to solve these problems, and even if you think you're a master at solving these problems, you should still follow the setup of sorting out the variables that you have. If you sort them out and label them and give them names and give them identities, you are a lot less likely to make a mistake plugging into a formula, and you're more likely to get the answer you want. So let's go ahead and do that. So you have four variables you're looking for with an acceleration formula: acceleration, velocity final, velocity time, and velocity initial, and time. So let's read through this and see what we got. A car accelerates at a rate of 5.0 meters per second per second. Remember, acceleration is the rate at which you change velocity. So a meters per second is 3 units. That gives me a hint, that tips me off that that's my acceleration. And then it also says it accelerates. And just a quick reminder, if you didn't catch this in the first video, what this unit is saying is that every second this thing is traveling, it gets 5 meters a second faster. That's all that means. So now we put that there. Alright, what was the initial velocity if the car is going 75 meters per second after 9.2 seconds? What was, and you might be thinking, oh, Miss Scott, that's a little silly that you point that out, but you should look for those question words in these problems. That tells you directly what you're looking for. I can't tell you how many times I have students, very bright students, say, I don't know how to get this answer, because they've plugged all this stuff in, and it turns out they're looking for something that they don't need to find. And what they plugged in ended up being the answer. So, what was the initial velocity? That means I don't know VI. Question mark. If the car is going 75 meters per second after 9.2 seconds. So, time, 9.2 seconds. And velocity final, I end up, after that amount of time, I end up going this fast. So it's at 75. So I have everything nice and neat and organized. Yay! So now we can use it in a way that's beneficial for us. So let's go ahead, I'm going to scoot you over. Let's plug what we know into our formula. So A, 5 meters a second per second is equal to VF, 75 meters per second, minus, I don't know what VI is yet, so I'm just going to leave it as its letter VI, V subscript I, over letter T, 9.2 seconds. Now you might be wondering, okay, what do I get rid of first? Because our goal is, ultimately, to get rid of, get VI by itself. I want to cancel everything else out. I want to get rid of it and pretend it doesn't exist, and get VI by itself. Well, you have one of two options. Remember, when you're doing basic algebra, to get rid of something on one side, you do the opposite operation. So this, you are basically adding this number to a negative VI. So you can subtract this number, or you're dividing by this number on this side, you can multiply by this. when you have units that are not the same. So here's seconds and meters per second and meters per second per second. You can't add and subtract those. I tell this to my physics class all the time. I'm 5 foot tall. I am 5 foot tall. If I put on 5-inch heels, I'm not 10 feet tall. I might feel like it, but I'm not. I'm 5 foot 5 inches. You can't add those numbers together because they're different things. You're saying two different things. So, first thing I'm going to do, I'm going to multiply both sides by 9.2 seconds. You'll see that? No, you can't. 9.2 seconds over 1. You can make anything a fraction by sticking a 1 underneath of it. That goes away. That goes away. Sweet. Multiply this. And I'm going to put it under, like you would be multiplying side by side. Obviously, I'm not doing anything weird. I promise. And what that leaves you with, and if you wanted to see how the units cancel out, see how the units cancel out? I have a second here and a second here. One in the numerator, one in the denominator. I can get rid of both. That 9.2 stays though. So 5 times 9.2 turns out to be precisely 46 meters per second. And that equals the remainder of this equation, 75 meters per second minus VI. Okay? So we're getting there. Now, I have meters per second and meters per second. Now I can do my adding and subtracting. No problem. No problem. Am I going to get rid of this 75? It's a positive 75 on this side. So I'm going to subtract 75. Take 75 away. That makes that go bye-bye. And you might be saying, Miss Scott, you are taking a little number and you are subtracting a much larger number. You're going to get a negative velocity. Isn't that weird? No. No, it's not. You do end up getting a negative number. Velocities inherently can be negative, depending on what you assign a negative direction and a positive direction. Here you're not doing that though. Let me show you. Oh shoot, we're running out of room here. That's okay. I'm not paused, am I? No, I'm not. Okay. I just did something weird. Alright, so 46 minus 75 does indeed leave you with a negative number. A negative 29. And you can't see that negative. Negative 29 meters per second equals, now look at what it equals though. It equals negative VI. Well, I want VI, I don't want the opposite of VI. So are you going to get rid of that negative? Basically what you're doing is you're saying negative 1 times VI equals that. So you're going to divide, get rid of that negative. Negative 1. And that leaves you with a VI positive 29. Now if you want to go back and kind of think through this, a lot of my students like to have numbers that kind of make sense, whatever that means. If I go back to the definition of acceleration, the definition of acceleration is the rate at which velocity changes. Well, my acceleration is 5 meters a second. That means every second it travels, it's getting about 5 meters per second faster. Okay, well, I ended up at 75. I was traveling for, I'm going to say about, I'm going to round down because it's closer, about 9 seconds. That means I should have expected to get about 45 meters per second faster. 29, 75 minus 29 is 46, a little, 46, 5 times 9, 45. Yeah. So if I rounded down, I would expect that my velocity would increase, because I have uniform acceleration, that would increase by about 45 meters per second. And looky there, it did. It increased 46 meters per second. So yes, this answer makes sense, that it was going 29. After about 9 seconds, it got up to a velocity of 75. So I'm going to leave that there with this video. If you need any more assistance or have any more questions about these kinds of problems or this way of solving, please let me know in the questions and or ask me in class if you're one of my students. And until then, have a great day.